Hello and welcome to the section 2.2 lecture today. Today we're going to be looking at how we can make lines parallel. Going to be pretty similar to yesterday's stuff. The first thing I want to look at is what in algebra makes two lines parallel. What did we talk about back in our algebra days that makes lines go the same way? And if you're thinking slope, you're right. It is. In fact, lines with the same slope would be parallel. Okay, same rise over run. That's what makes lines, that's what affects whether they're parallel or not. It doesn't matter what the y-intercept is, it all is dependent on slope. So as we look at slopes of lines, that would be one way to check to see if lines are parallel. What we're actually going to do, since we're kind of in this geometry mindset, is that we're going to focus on some kind of lines, hopefully parallel, cut by a transversal. And we're gonna focus on a couple of the special angles that we've talked about yesterday specifically, and use those to judge if they're parallel. Kind of where all this comes from, I don't remember if I talked about this yesterday or not, was the man that wrote the book, okay, Euclid. We're studying Euclidean geometry, and his fifth postulate, his fifth fact that he brought up was if there's two lines that intersect a third line at different spots, so he says it that way, and that's just two lines cut by a transversal, in a way that two angles on the same side, let's just say for now angle 1 and angle 2, add up to less than two right angles. These are specific words from how he wrote it. And so two right angles would be 90 plus 90 or 180 degrees. So if they add up to less than two right angles, so if the measure of angle 1 plus the measure of angle 2 is less than, okay, now that I wrote that, it's not going to fit there. Come on over. Is less than 180 degrees. That's the way he says this, which is kind of weird once we get to what this statement's actually called. If it's less than 180 degrees, then eventually these two lines are going to meet on this side. It was such a big statement. People had a really hard time with it because there was a lot going on to break it down. And people had a hard time with it because you were given so much information. You should be able to show that that's actually going to happen. And it can't be proved. That's why he treated it as a fact that he was able to assume and therefore let everybody else assume. So if they're less than two right angles, then the lines are going to meet over there. Now, what is kind of hidden in this fact, this fifth postulate, is called the parallel postulate. But if you notice here by his setup, there's nothing parallel. My lines aren't parallel if those two are less than 180 degrees. Those lines are going to meet. And he even says in that statement that those two lines are going to meet specifically on the side where those two angles are less than 180 degrees. Now, I would want you to do a little investigating. And if angles 1 and 2 add up to less than 180 degrees, what do you think angles 3 and 4 add up to give you? These two then would be bigger than 180 degrees. If those two are less, then those two are bigger. And it's at the break-even point that we really care, and we kind of learned that yesterday, that if they're equal to 180 degrees, if angle 1 and angle 2 equal 180 degrees. Now, we didn't say this yesterday, we said kind of the opposite, but it turns out that when angle 1 and angle 2 add up to 180 degrees exactly, then the lines are parallel. And that's one of the big facts today. In fact, let's go ahead and put that one in. 1 and 2 are consecutive interior angles. The two lines are parallel if those angles add to 180 degrees. Okay? On all the rest of these that we have above this, corresponding angles. We talked about yesterday, if the lines are parallel, then corresponding angles are congruent. Today is just the opposite, that the lines are this doesn't sound opposite, but it's based on where the if is. I would probably say if a pair of corresponding angles are congruent, then the lines are parallel. And it turns out that all these other things happen as well. That if a pair of alternate interior angles are congruent, then the lines are parallel. If a pair of alternate exterior angles are congruent, then the lines are parallel. So it's really just a review from yesterday, but it's technically saying things in a different way. Today we are forcing the lines to be parallel, where yesterday we were given that the lines are parallel. So you can tell by the way these questions are asked that this is asking us for what missing angle measure are the two lines parallel. So I want to make these lines parallel, and they're going to be parallel as long as this is 106 degrees to match this 106, because those are alternate exterior angles. Those ones are alternate exterior angles. On the next one, they're consecutive interior angles, so they have to add to 180. So somehow the question mark plus the 52 has to equal 180. I would say that's probably 128 degrees. If that was 128 degrees, then those lines would be parallel. Okay, these two are alternate interior angles, and if they're the same, if they're congruent, then the lines are parallel. The last pair over here are corresponding angles, and if they're congruent, then the lines are parallel. That's what we're working towards through all these problems. On these last couple, we want to kind of do the same thing, but we've got some variables involved. On this one, they're corresponding angles, so in order for these lines to be parallel, I want this one to also be a 70-degree angle, and I've got to figure out what x has to be to make that equal to 70 degrees. Go ahead and subtract 14 from both sides. And we'll get 7x is equal to, 56? And so x would have to be 8, because 8 times 7 is 56. On the last one here, these are consecutive interior angles, so we want them to add up to 180 degrees, and there's kind of two ways to do this. I could either say that I want 6x plus 19 plus the 95, so there's one angle, there's the other angle, to add up to 180 degrees. Some people working a little bit ahead of the game say, well, if that one's 95, then we want that one to be equal to 85. And you could do that. You could write out this equation right here and solve it, and you'd get the same answer for x. We're going to do it this way because it's more painful. I mean, I don't really have a good reason as to why, but that's okay. That's plus 114 equals 180, so I just combine those like terms right there. I want to subtract 114, and I believe that's what, 66? Oh, that would mean that x would have to be 11, because 11 times 6 is 66. Okay, hopefully you got something out of that. If you have any questions, make sure you let me know. Otherwise, have a great day, and we'll see you in class.